Hi, I'm Cosmos from the CoreOS storage team. Let's talk about hyperconverged infrastructure. HCI is rapidly becoming the way that organizations modernize on-premises infrastructure. By consolidating from proprietary dedicated storage arrays and network appliances to simply industry standard servers that bring their own software-defined storage and networking, organizations around the world are lowering costs, increasing performance, and simplifying their operations. In fact, according to research by the Enterprise Strategy Group, 54% of organizations with a mature data center modernization strategy expect that deploying hyperconverged infrastructure will be among their most significant IT projects for the next 12 to 18 months. And that's not just aspirational talk. It's already happening. According to data from IDC, hyperconverged infrastructure investment grew 57% last year. It's now nearly $2 billion per quarter. That's a lot of spending, and it means a lot of opportunity for you in IT. It's an exciting time for on-premises infrastructure and especially hyperconverged infrastructure. So how do you get from the Hyper-V you already have to hyperconverged infrastructure? The key is Windows Server 2019. The latest version of Windows Server includes everything you need to deploy and manage HCI, including Hyper-V, the foundational hypervisor of the Microsoft Cloud, software-defined storage, specifically Storage Spaces Direct, software-defined networking, and Windows Admin Center, the future of Windows Server management, which is no additional cost beyond your Windows licenses. What's more, together with our partners, we recently launched the Azure Stack HCI Solutions program. An Azure Stack HCI solution combines all of this with pre-validated hardware that's designed and tuned especially for hyperconverged infrastructure, so you get up and running quickly and smoothly. Another way to look at it, it's the same hyperconverged compute, storage, and networking with the same hardware testing and validation criteria as Azure Stack, but instead of being geared toward running IaaS and PaaS with an Azure Consistent Portal, it's a more familiar way to run virtualized apps on-premises with increased efficiency. Between Windows Server 2019, Windows Admin Center, and Azure Stack HCI, there is a lot to cover. To help us unpack it, I'd like to introduce my colleague Greg from the CoreOS networking team. Hi, Greg.
Hi, Cosmos.
Here's what we're going to do, a lightning round. We're going to cover 25 things you need to know about HCI in just 25 minutes. It's going to go fast. So we're also publishing a blog with accompanying details and links to documentation so you can learn more about anything we cover. All right, Greg, you ready?
I'm ready.
Let's do this.
All right.
First, we have to start with the Azure Stack HCI solutions. Launched earlier this year, these are a big deal because they really unlock all the infrastructure capabilities of Windows Server 2019 for broad deployment and on a broader range of compatible hardware than ever before. In fact, there are already over 70 solutions available from our 15 partners, covering all corners of the world and available for purchase right away. And now, you can browse them directly on Microsoft.com in a completely new Azure Stack HCI catalog. In your browser, navigate to Microsoft.com/HCI. That'll take you to a marketing page with a big blue button labeled Catalog. Click the button, and here you'll see a rich store-style experience where you can browse and filter all the available solutions. For example, maybe you're looking for an HPE solution that's all-flash with iWarp networking and available in Europe. Well, there you have it. You can even click the one you're interested in to link directly to the right page on the partner website so you can learn more and engage with their sales team. Now, Greg, I noticed the HCI catalog no longer makes a distinction between HCI Standard and HCI Premium, which used to mean SDN. So what's changed?
Well, Cosmos, now all HCI solutions include what is required for SDN. Now, it doesn't mean you have to devote the entire infrastructure to SDN. You can have networking with your VLAN configurations coexist side by side with SDN on the same hardware. Let's take a look. You can go in through Windows Admin Center, select Network or Virtual Network, and your machine will get whatever settings it needs.
Now that's great, but there's still the small matter of actually deploying SDN, right? How do I do that?
Well, that's easier than ever. With SDN Express, you can go to GitHub, download a set of scripts called SDN Express, And then you run SDN Express, and you'll get a very helpful wizard that'll walk you through all the steps you need to get SDN up and running in probably about 30 minutes or less.
Now, we can't talk about what's new for hyperconverged infrastructure without talking about the most visible and obvious thing, and that's Windows Admin Center, the future of Windows Server management, and certainly the future of hyperconverged infrastructure management. In fact, in Windows Admin Center, there's a rich set of dedicated screens that are especially for managing storage spaces direct and software-defined networking. You can easily do things like provision volumes, monitor storage spaces jobs, get a view of your virtual machines across the whole cluster, including the resource consumption, and dive into troubleshooting your hardware with rich information about servers and drives.
And with SDN, you can configure your virtual networks, you can configure access control lists, and set up the gateways that your applications need in order to get outside of their virtual networks as well.
When Storage Spaces Direct first launched in Windows Server 2016, by far the top feedback was a request for a better user interface. And that's what we've delivered with Windows Admin Center. The next most requested feature was deduplication and compression for the Resilient File System, REFS, Microsoft's recommended file system for hyperconverged infrastructure. Deduplication and compression is a technology that saves you space by identifying duplicate portions of files and then only storing them once. The savings you can expect depend on what you're storing, but they can range from about 30% for videos and music all the way up to about 90% with highly repetitive workloads like ISO files, VHD files, and especially backups of those files. To make that clear, 90% savings means you get up to 10 times more usable storage capacity for free. And it's easier than ever to turn on deduplication. It's just a single click of a rocker switch in Windows Admin Center. Sometimes, even with features like data deduplication, you just need a lot of raw storage capacity. This is especially true for use cases like backup and archival. In Windows Server 2016, the maximum storage capacity in a single cluster was 1 petabyte. In Windows Server 2019, that has increased by a factor of 4 to 4 petabytes. To put that in perspective, that's enough space to store all of Wikipedia in every language with complete edit history, uncompressed, 50 times. And that's not just a theoretical number. In fact, at Microsoft Ignite last fall, we partnered with our friends at QCT to build such a system. With 8 of their biggest 4U rack mount servers, we built what we believe is the largest Storage Spaces Direct cluster ever outside of a public cloud, at very nearly 4 petabytes. With Azure Stack HCI, you can deploy anywhere from 2 to 16 server nodes in a single cluster. And you can always start small with, say, 4, and then add a 5th, 6th, 7th, and so on to scale with the needs of your organization. But what if you want to deploy hundreds or thousands of server nodes? Well, with Windows Server 2019, now you can. Suppose we start with these 8 servers in a cluster. What's new in Windows Server 2019 is we can encapsulate this cluster in something called a cluster set. And, you guessed it, we can add additional clusters into the same cluster set. What's important is this cluster set will present a unified storage namespace, which means a virtual machine running on one cluster can seamlessly live migrate to a host in a different cluster and continue to access its storage, even though its storage stayed behind.
In 2016, we shipped SDN, and we heard a lot of feedback from customers that they want to have faster gateways. So we've worked to improve in Windows Server 2019 the gateway performance. In many cases, we've improved by over 3 times. If you have enough connections, you can go from 4 gigabits per second up to 18 gigabits per second through a single SDN gateway. This is for GRE tunneling. And one of the really good use cases for GRE tunneling is in connecting 2 network controllers that are running in different sites so they can connect their virtual networks and have the workloads running in each talk to each other as if they're one network.
With each release, Windows Server gets more scalable. The numbers get bigger. And it's not just about capacity, it's also about performance. Windows Server is on the leading edge of x86 hardware innovation, consistently one of the first operating systems and hypervisors to support new hardware technology, like the latest Intel Xeon Scalable processors, remote direct memory access, RDMA networking, NVMe drives, and now Intel Optane, including Intel Optane DC persistent memory. These are 3D crosspoint-based persistent storage that's DDR4 pin compatible, meaning it goes into a memory socket. Last fall, at Microsoft Ignite, we teamed up with Intel and built a 12-node cluster packed with Intel Optane DC persistent memory. And we used it to set the HCI industry record with over 13.5 million IOPS from a single cluster.
So it's not just about hardware enablement, but we've also been making a lot of improvements to the networking stack as well that benefit either the host or the guest, and in some cases both. We made an assortment of feature improvements both to TCP/IP and UDP performance, nearly doubling the performance. We implemented receive-side coalescing in the virtual switch, which gives you a great improvement in throughput while reducing the amount of CPU utilization at the same time. We changed congestion providers for TCP, defaulting to cubic, which gives you higher performance across high bandwidth but high latency links. And finally, for the guest, we implemented the Data Plane Developer Kit, or DPDK for Windows, which gives applications like video processing the ability to get really fast access to the packets, bypassing the host networking stack.
Now, it's not just the Windows networking team that's been focused on optimizations. We have been on the storage team as well. One example is with mirror accelerated parity, a technology that allows you to create a volume that partly uses mirror resiliency and partly uses parity or erasure coding resiliency. This lets you get the best of both, fast writes into the mirror portion, and then maximized capacity through the efficiency of parity encoding. If we take Windows Server 2016 as the baseline, the performance of mirror accelerated parity has more than doubled in Windows Server 2019. With all that capacity and performance, you're going to want to be able to see it. And with Windows Server 2019, you can. Hyperconverged infrastructure now has built-in performance history, so you can easily get data from an hour ago, yesterday, or last week. There are over 50 key performance counters spanning processor usage, memory, networking, storage, latency, and much more that are automatically aggregated and stored. There's nothing you need to set up, install, or configure. It just works. You can access it in Windows Admin Center, where you'll notice that the charts have a time range picker allowing you to go back in time. And for more advanced scenarios, you can query using PowerShell. You know, I can't believe we're more than halfway through and we haven't even talked about Core Hyper-V yet.
I know, that's right. We've made improvements to things like shielded virtual machines, where we've improved it so that even if you don't have network access to your VM, you can still connect to it, either through the console or through PowerShell Direct. And we've also added the ability to run Linux inside your shielded VMs with distributions such as Ubuntu, Red Hat, or SUSE.
Now, regardless of whether your organization has adopted shielded virtual machines yet or not, it's important to protect your hypervisor host. And that's never been more true than in the last year, where vulnerabilities like Spectre and Meltdown have really shined a bright light on side channel attacks. In Windows Server 2016, Hyper-V used something called the Classic Scheduler, which provides a fair share preemptive round-robin scheduling for virtual processors essentially at random. In Windows Server 2019, there's a new Hyper-V scheduler type called the Core Scheduler that is the new default. This further constrains virtual processors to the physical core boundaries, further isolating VMs. It's the default in Windows Server 2019, but you can actually use the Core Scheduler on Windows Server 2016 as well. Microsoft backported it last fall in a cumulative update. In Windows Admin Center, under Hyper-V settings, you'll see a new radio button called Hypervisor Scheduler Type, which you can switch from Classic to Core.
So we've also been working to improve web traffic that comes and goes from a Windows Server machine. We've done this through HTTP2, a technology that we first shipped in Windows Server 2016, but we've made it better in Windows Server 2019 by implementing things such as connection coalescing, which allows websites with a common second-level domain to share the same certificate and, as a result, the same TCP connection. This gives you fewer round trips to the server and better overall performance for your web applications. At the same time, we've also improved the cipher suite selection process, which reduces the number of connection failures, while at the same time still enforcing the blacklisted ciphers that are no longer secure.
In Windows Server 2019, the core failover clustering technology gets more secure as well. In particular, Failover clustering will now use exclusively Kerberos or certificate-based authentication for all cluster and storage traffic between nodes. This means the dependency on the NT LAN Manager or NTLM protocol is completely removed. There's no change required by users or deployment tools to make this work. It's just the out-of-box behavior. Speaking of clustering, an important part of the operation of any cluster is keeping your Windows servers fully patched with the latest updates. And it's never been easier than with cluster-aware updating for HCI. Cluster-aware updating is a technology that orchestrates the rollout of updates across clustered server nodes. Essentially, it takes the pause, drain, install, restart, and resume workflow and repeats that across all nodes in the cluster for you. And now, in Windows Server 2019, it's even better. It has special integration with storage spaces to wait after each node restarts for storage resync to complete. And it more deeply integrates with Windows Update to check if an update really truly requires a restart, and it only pauses and drains nodes if the update does require it, minimizing disruption to virtual machines. And with Windows Admin Center, you can easily check for updates and kick off an updating run with just a single click, with an all-new cluster-aware updating tool that looks almost exactly like the Windows Update tool for a single machine. Let's talk about quorum. When you deploy a cluster in your core data center with like 6 or 8 or 12 nodes, you don't really have to think about quorum. But our telemetry shows us that with HCI, you're more often deploying at the edge, in branch offices, remote sites, or field installations, taking advantage of HCI's minimum footprint of just 2 servers with 4 drives each. You don't even need a switch. You can just wire them back to back with a crossover cable. In these kinds of 2-node clusters, thinking about quorum is essential. In Windows Server 2016, there were 2 ways that you could use a witness to provide quorum to a 2-node cluster. You could use a file share from another on-premises server, or you could connect to the Azure cloud for a cloud witness. But what about deployments that maybe don't have any other on-premises infrastructure and don't have a reliable connection to the internet? Windows Server 2019 introduces a third option, the USB witness. Literally just plug a USB key into a compatible router or switch, and the cluster will use that for quorum. Whenever you deploy a cluster, even a small one, you're doing it for high availability, for fault tolerance. Yet just last year, there was no HCI solution available from any vendor where the storage could survive multiple simultaneous failures with just 2 nodes. The reason is that with a 2-node cluster, storage resiliency is provided using two-way mirroring, essentially keeping 1 copy of data in each server. This means you can survive a drive failure, or you can survive a node failure, but if both happen at the same time, your virtual machines go down because they lose access to their storage. This wasn't great, so our engineering team took inspiration from an old technique called RAID 51, or RAID 5+1. The idea is to do parity resiliency within one server, and then mirror that across to the other server, giving you parity on the other side as well. This is what's often called a nested RAID level. And in Windows Server 2019, Storage Spaces has a new resiliency type. It can now do nested resiliency. This means you can survive multiple simultaneous storage failures even with just a 2-node cluster. That includes a drive failure in each server at the same time, or a drive failure and the other server going down. Both are totally fine.
While storage resiliency is important, it doesn't eliminate the need for backups. But for smaller sites and branch offices, it doesn't make sense to have costly backup infrastructure on premises. But for that, we have Azure Site Recovery. And now Azure Site Recovery is integrated into Windows Admin Center with a one-click experience that lets you back up your VMs to Azure, where they're safely stored.
Now, typically, you don't just have one branch office. That's why you call them branch offices. And small branch offices may not have dedicated IT personnel to respond to problems. So you need to monitor the HCI you deploy to all your branches centrally. The Health Service is the component in Windows Server that provides the alerts you see on the Windows Admin Center dashboard. And now it integrates with Azure Monitor. Simply install the Azure Monitor agent on each server in the cluster, and then when something goes wrong in any branch office, say a server goes down or you're running out of capacity or perhaps a drive fails, Azure Monitor will send you an email or SMS notification showing you all the details of what's happened so you can dispatch someone from headquarters to respond.
Now, as you move more workloads into Azure, the need to connect to Azure becomes even more important. But when you have many branch offices, each one with their own infrastructure, it becomes difficult to deploy site-to-site or express route to every one of these sites. So for that, we built Azure Network Adapter. This is an integration into Windows Admin Center that makes it very easy to connect a single server running pretty much anywhere to an Azure virtual gateway so you can get access from that server into your Azure files or your other Azure VMs running in Azure. To find Azure Network Adapter, go to the networking settings of any server in Windows Admin Center and just click on the Azure Network Adapter button. Now, when you have a lot of remote offices or smaller offices, they may not always have a really fast connection to the internet. And so for these offices, you want to make sure that any background traffic that's going between them or your core data center or to Azure gets a lower priority. And for that, we have a really good technology in Windows Server called LEDBAT, which is another congestion provider that will back off these lower priority network flows in order to let the higher priority traffic take over. And when that higher priority traffic slows down, then the low priority traffic will pick back up again, usually within a second or two. This is easily enabled either through PowerShell or through SCCM for distributing updates just by going to your distribution point settings if they're running Windows Server 2019. We're almost out of time. And speaking of time, for those of you that are in regulated industries where you need to have really accurate clocks, sometimes down to microsecond accuracy, we made a lot of improvements to get you there by implementing features such as precision time protocol, software timestamping, even additional granularity on the clock to get it more accurate. We've implemented traceability, which gives you the ability to go in and see the logs where your clocks were set so that you can go back and prove that your clock is as accurate as it needs to be. And finally, we added leap second support. Cosmos, did you know that every few years, a second can get added or removed from the clock?
So literally just some minute will randomly have an extra second?
Yep, that's right. Take a look at the screen. You'll see one in action right here.
Whoa!
There it is, 60 seconds.
Weird!
You don't see that every day.
Finally, number 25. This one's not a new feature, but it's an important milestone. Last year, around this time, we shared that 10,000 clusters around the world were running Storage Spaces Direct, far exceeding our wildest expectations for how quickly you, the Windows Server community, would roll out this technology. Well, 1 year later, I'm humbled to share that over 25,000 clusters worldwide are now running Storage Spaces Direct. This is an astonishing rate of growth since last year. The momentum is just amazing. On behalf of the Windows Server engineering team, we want to thank all of you, the community on Twitter, on Slack, on TechNet, our wonderful partners, and of course, our customers. Thank you for your trust and your business. All right, that is it for our lightning round. We did it. 25 things in 25 minutes. Was this a good format? Should we do more sessions like this one? Let us know. Tweet us with the hashtag below and tell us what you think. As you can see, it's an incredibly exciting time for on-premises infrastructure, and especially hyper-converged infrastructure. Whether you're deploying a tiny 2-node cluster or at petabyte scale, whether you need the best performance or the best security, or you just want that gorgeous new dashboard in Windows Admin Center, HCI gets better for everyone with Windows Server 2019. To get started, find solutions from your preferred hardware vendor at microsoft.com/HCI. Install Windows Server 2019 from aka.ms/Windows Server. Manage with Windows Admin Center, which you can download from aka.ms/Windows Admin Center. And, optionally, connect to helpful Azure services that make on-prem better. And be sure to watch the rest of the Windows Server Summit, including Haley's session, where she'll tell you more about that. Thank you very much.